we have something for our wonderful viewers, and it goes as follows. A plastic sphere floats in water with 50% of its volume submerged. If it floats in glycerin with 40% of its volume submerged, the density of the glycerin is given that the density of water equals 1,000 kilogram per cubic meters. A, 1,400 kilograms per cubic meters. B, 1,250 kilograms per cubic meters. C, 500 kilograms per cubic meters. And D, 1,500 kilograms per cubic meters. All right, in a question like this, there's one background knowledge we must have, and that background knowledge is that the mass of the sphere, both in the glycerin and in the water, is the same. Because when we have this background knowledge, then we'll be able to, make headway in this question. All right, let's get the data or the givens provided by the question. Let's go. A plastic sphere floats in water with 50% of its volume submerged. So meaning that the volume of the sphere in water, VW, is 0.5. That of the sphere is submerged, okay? Vs means for the sphere, volume of the sphere, right? Then next, if it floats in glycerin with 40%, okay, so in glycerin, Vg, the volume in glycerin is 0.4, that of the sphere. Now, how did I get the 0.5? 50 over 100 is 0.5. 40 over 100 is 0.4. Take note of that, okay? Then we are looking for density of the glycerin, rho G, okay? Given that the density of water, rho W, is 1,000 kilograms per cubic meter, all right? All right, so let's go by first getting we know that density rho is equal to mass over volume, okay? And if this is the case, we can get mass of water because we have the density of water. We also have the volume of the sphere in water. So let's go. So here, this is for water. Let's say rho W, MW, VW, right? So MW will be equal to rho, if we make MW the subject, it will be rho W times VW, all right? So rho W, according to the question, is 1,000 times VW is 0.5 Vs. So all of this would give us 50 Vs. This is the mass of the water, okay? And mind you, mass does not change as far as matter is concerned. So mass is constant. So this also implies that mass of the glycerin Mg is equal to mass in water Mw, which is what? 50 Vs. Okay? All right. So let's now move over to that of the glycerin. Okay? So that of the glycerin says that rho G, density of the glycerin, equals mass of the glycerin Mg over the volume of glycerin, that is a Vg. Okay, remember we have Vg here. So if we substitute, it will be Mg here is 50, it will be 50 Vs over Vg is what? 0.4 Vs. So this cancels this. So 50 divided by 0.4 would give us 1,250 kilograms per cubic meter. It is this simple. So from our options, our answer is B. All right. Thank you for watching. Remember to like, share, and subscribe to our channel.